The thermal shadow of radiation, often referred to in the context of nuclear explosions, is a haunting visual phenomenon that results from the intense thermal radiation released during a nuclear blast. This radiation travels outward from the explosion and can burn surfaces, leaving behind distinct shadows of objects or people that blocked the radiation. When a nuclear explosion occurs, a massive amount of thermal radiation is released in the form of heat and light. This radiation is so powerful that it can instantly scorch or char surfaces, like concrete, asphalt, or metal, within the blast radius. If an object or a person is standing between the surface and the explosion, they can block part of the radiation from reaching the surface behind them. As a result, the area shielded by the object or person remains unscorched, while the surrounding area is charred. This creates what's called a thermal shadow, a lighter or unburned area in the shape of the object or person, contrasting against the darker, burned surface around it. The most well-known instances of thermal shadows were observed after the atomic bombings of Hiroshima and Nagasaki during World War II. In Hiroshima, after the bomb detonated, shadows of objects like railings, trees, and even people were left imprinted on the ground or walls of buildings. The most famous thermal shadow is known as the Hiroshima shadow, which shows the outline of a person who was sitting on some steps when the bomb exploded. The intense heat vaporized the person, but the steps behind them retained the shadow of where they had been sitting. Distance from the explosion: the closer an object or person is to the explosion, the more intense the radiation, and the more clearly defined the thermal shadow. Farther away, the radiation weakens, and the shadow becomes less distinct. The type of material on which the shadow is cast also influences how well the thermal shadow forms. Darker surfaces absorb more radiation and are more likely to show clearer shadows, while lighter surfaces reflect radiation, making shadows less visible. The shape and size of the object blocking the radiation determine the size and outline of the shadow. Nuclear explosions release three types of radiation: thermal radiation, blast waves, and ionizing radiation. The thermal radiation consists of heat and light energy, which can char surfaces and cause burns. Objects or people act as shields, absorbing or deflecting the thermal radiation. The areas that are protected do not experience the full brunt of the heat, so they are left unscorched. Thermal shadows remain a stark and grim reminder of the devastation caused by nuclear weapons. They offer physical evidence of the sheer force of thermal radiation and how it interacts with the environment. Today, the study of thermal shadows can help scientists understand more about the effects of nuclear explosions, including the distribution of thermal energy, the intensity of the blast, and the radius of destruction. The thermal shadow of radiation is a powerful visual symbol of the destructive capacity of nuclear explosions. It is formed when thermal radiation from a nuclear blast is blocked by an object or person, leaving a contrasting imprint or shadow on the scorched surface. These shadows serve as reminders of the tragedies of Hiroshima and Nagasaki and underscore the immense power of nuclear weapons. Thank you for watching. We have some amazing videos coming up, so stay tuned for more updates on incredible science videos. And make sure to hit the subscribe button for more.